Hey VC students, welcome to another video of hok'stutoring. I hope you are doing well. Today we'll be going through a topic video and specifically we'll be talking about chapter 3A, 3B, 3C and 3D. So this is going to be on transformations of your graph. So linear equations, parabolas, square root functions, any types of graph that you're going to learn in methods, we're going to be able to apply these transformation techniques. So today, we'll be talking about how to find the new graph when you're given a sequence of transformations. So the questions are typically given in the format where you'll be given some kind of an equation, maybe square root x, and then the textbook or the sample exam or the exam would give you a list of transformations. For example, maybe a dilation, and then maybe a reflection, and then maybe some translation, all those sorts, and you'll have to find the new graph. So what is, y equals square root x turning into, okay? So that's generally the types of question that we're gonna get. So today, guys, we'll be going exactly through that. So stick till the end of the video if you want to get a further understanding of how to solve or how to answer these type of questions. I'm gonna give you some quick pointers and and a good technique on how to solve this. Okay, so let's begin with understanding the basics. So we need to know the three different types of transformations that you're going to learn in VC methods. So the first of them is the easiest one. We have translation. And in translation, essentially, and I'm going to use the mapping technique over here, and I'll show you what that means right now. So you have a coordinates, x and y, let's say that. And what translation does is it's going to shift your graph either left or right, but at the same time it can also shift it up or down, okay? So that's what translation is. But in terms of mapping technique, what we're going to do to our coordinates is if I shift my graph or my coordinates left or right, then that's affecting my x value, because x, on the axis is the one that determines whether your graph is going left or right. Okay, so in this case, we'll put that as plus h. So if your graph is shifting 2 units to the right, then you put x plus 2 because your coordinates is getting a little bit bigger, right? Your x coordinate is just getting shifted slightly to the right. And of course, if your graph is getting shifted to the left, then you put x minus 2 instead, okay? Same thing with the y. If the graph is shifting up, then you put a positive value, so y plus 2, for example. But if it's shifting down, then you put y minus 2. Okay, so it's very simple, nothing confusing at all. So that's translation for you using the mapping technique. So your coordinates, x and y, becomes x plus h, y plus k. And we'll go through an example later on where you can tackle all these things. You can see it in action. Right. So the second one is what we call dilation. And we might just need a bit more space for this one right here. With dilation, your x and y coordinates can do two things. So similar to translation where you can go either left, right, or up and down, dilation can be dilated from the x-axis, or it can be dilated from the y-axis. So I'm going to show you geometrically what that means. So let's say you have a graph, right? Parabola, a good old parabola, and this is the one point that we're talking about, x and y, okay? So that's our coordinate. And we want our graph to be dilated from the x-axis, okay? So now keep in mind, it's from the x-axis and from the y-axis. So this is where a bit of English comes into play, and this is more, I suppose, like mathematical term as well. If you are dilating from the x, okay, so where's the x? The x-axis is over here, the horizontal axis. You're dilating from that axis. So what does that mean? Well, dilating means you're getting bigger or smaller, right? Or you're like, moving away from something. So dilating from the x means you're actually shifting vertically. Your coordinates is actually shifting vertically. So it's from the x, okay? So that's what that means. And then when they say from the y, then that's saying, okay, my point here is just shifting by some factor horizontally instead, okay? So that's what it means from the y. So from that perspective, guys, when you are shifting or when you're dilating from the x, okay, from the x, so the one that's actually going up and down, then your x value does not change at all, okay? Your x stays the same, even though you're like, oh, it's shifting from the x, so therefore it should affect the x. Well, shifting from the x-axis is actually impacting your y value instead, because it's going up and down. It's dilating from that horizontal, so it's just shifting this way. Okay, so in this case, your dilation changes your y value. All right, so ay, if it's dilating by a factor of 2 from the x-axis, then you put 2y. If it's dilating by a factor of half from the y-axis, or from the x-axis, then you put half y. Okay, very simple. That's all you need to do. And same thing from the y. It does not, because from the y over here, it does not impact your y value. It actually impacts your x value. So moving horizontally, shifting away or closer to the y-axis over here. Okay, so in this case, it's going to change our x value, but our y value stays the same. So that's dilation from both axes. Okay, so this is very important. A lot of students confuses this. Make sure you understand this part, and it's very simple if using the mapping technique. And the last technique, reflection, this one, if you understand dilation, it's the same point. Okay, so you have the coordinates and you are shifting, or you are reflecting on two different axes. You have upon the x-axis, and then you have reflection upon the y-axis. So again, same thing, right? So if I'm going to draw my parabola again, and I have this as my coordinates, x and y. If I am reflecting upon the x, so where's the x-axis? It's over here. I'm reflecting upon it, okay? So meaning I am reflecting that way, okay? So what does that do to your x and y value? Well, you can see our coordinates here. The x stays the same, but the y value actually shifts. So what it does is it impacts your y value instead of the x value, even though the transformation is upon the x-axis. So don't confuse that, guys. If you are reflecting upon the x-axis, you are changing your y value, and vice versa. If you're reflecting upon the y-axis, you are changing your x value instead into just negative. That's it, -1 times whatever coordinates you have. So guys, that is the basics of mapping for transformation. So you've got translation, very simple, plus h plus k. You've got dilation, which is just multiplying your coordinates by a number, a factor. And same thing with reflection, you multiply your coordinates with a -1. That's it. And now we're gonna go and tackle the main topic of today's video, which is finding the new graph when you're given a sequence of transformations. So I'm gonna go through a quick theory lesson first, and then we'll go through an example shortly after that. Right. So with these types of questions, I usually go through the mapping technique because I find that the most efficient, and that's what the book does as well. The theory behind this is, if I have an x coordinate and a y, or if I have a coordinate and I've got my x and y value, then what I'm trying to do is I'm trying to, when I apply transformation, it becomes a new x and it becomes a new y. I'm going to call that x prime and y prime. Now, of course, x prime and y prime is given by some kind of transformation, right? So x prime is, x, the old x, the original x right here, added with some transformation on top of that. So, maybe x plus h, and then divided by a or something, and then maybe this is a times y, blah, 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 all that kind of transformation that we covered up here. We're going to apply that transformation. That's going to become our new x and our new y. So essentially, you can write x prime and y prime as your, bunch of different transformation applied to your original x. So for example, maybe x plus h and a y in this example, okay? So this is the basic theory. We're going to use that to help in today's video when we do this example right here, and I'll show you guys how to use this down over here. So alright guys, so we're going to go through an example over here. This is going to be on question 2, and I've just taken a snippet of from your textbook, and we're going to transform our graph y equals square root x into something when you're given this sequence of transformation up top over here. So let's have a read. You have a dilation of factor 2 from the x-axis, followed by a reflection on the x-axis, followed by translation 3 units in the positive direction of the x-axis and 4 units in the negative direction of the y-axis. Okay, so you need to do this one step at a time, and we're going to use the mapping technique up there. I've put a cheat sheet on our right so that we can reference to it whenever we need to. Okay, so first of all, you have your coordinates, right? X and y, and we are going to transform it so that, it's now the new x and the new y. We want to make it in terms of the new x and the new y. Well, another way of writing the new x and the new y is by applying the list of transformations up here, right? So let's have a look. First of all, you have a dilation of factor 2 from the x-axis. So using our cheat sheet, right? Dilation by a factor of 2 from the x-axis. So it's the first one over here. And we are changing the y value in that instance, okay? So that a is pretty much just 2. So if we're doing this one step at a time, then your x value becomes x. It's still the same. So the x prime and y prime is equals to whatever we're going to find over here. We're going to change the a to a 2, dilation by a factor of 2 from the x-axis. So that's that. That's number 1, tick. And then we're going to keep going, followed by a reflection in the x-axis. So using our reference, our cheat sheet again, when you are reflecting upon or in the x-axis, you're reflecting, well, look at our graph, right? If this is our point, you're reflecting in the x-axis or upon the x-axis, you're going this way. So you're actually changing the y value, right? So again, your transformation second step would look like this. You are changing the y value. So that's tick. And then we're going to go followed by a translation of 3 units in the positive direction of the x-axis. So this is telling us that it's shifting 3 units in the positive direction, meaning to the right of the x-axis. So in that case, we put a +3. So don't get that confused, even though it's in the x-axis. When it comes to translation, take it as it is. You're moving along the x-axis. That's what it means. Your y stays the same, and we just have one final transformation right here, and that is 4 units in the negative direction of the y-axis. So you have x +3 and then negative 2y minus 4. Okay, so your x and y has been mapped to this, which is actually the same as x prime and y prime. Okay, so your new x is now given by this transformation, your new y is given by this transformation. So in algebra, or you can write this down as an equation, your x prime is equals to x +3 and your y prime is equals to negative 2y minus 4. Well, what you can do is we're trying to show y equals root x in basically in the format of the new x, right? And in that instance, your equation, your new equation, has to be y dash equals to x dash and then blah blah blah, some kind of function of x, x dash, right? X prime. So in this case, we can take advantage of that and say, if I have my equation right here, y equals to square root x, I can replace the y so that, it's in terms of y prime, and I can replace the x so that's in terms of x prime. So I can substitute in my y values in terms of y prime, my x values in terms of x prime. What I mean by saying that is you can take advantage of this equation right here. So x, the original x can be, you can manipulate your equation, and x can equals to x prime minus 3 and y can equals to, well, let's do a bit of algebra, y prime plus 4 and then you divide it by negative 2, right? So you can manipulate your equation a little bit so it looks like this. And what you can do is, now that you have x in terms of x prime and you have y in terms of y prime, you can substitute these new equations into your original one, the graph that you want to transform. So you have y over here, we're replacing that with y prime plus 4 divided by negative 2, and then that is equals to square root x. Well, we're replacing x now with x prime minus 3, and all you need to do, guys, now if you want to find the new equation after this sequence of transformation, is just find y prime in terms of x prime, put into a nice format so that y prime is a subject, and then you get the your final equation. So let's do that. We have y prime plus 4 equals to negative 2 times by square root x minus 3, and then you have y prime equals to negative 2 times by x prime minus 3 and then minus 4. So guys, your new equation, and yes, the x prime, the y prime, it's not typically what you see in an equation. So if you want to write your final answer and you want to make it look nice, you can essentially just remove the prime and then this graph right here, y equals to -2 times by your square root function plus 4 is your new graph after your transformation, from y equals to square root x, and the transformation that was given in the question up there. Okay, so that, guys, is the mapping technique that I wanted to show you. I hope that was useful and I hope you understood that. If you have any questions, please leave a comment in the comment section down below. I'll be going through more questions to help you further understand this transformation technique, because it is quite useful and it's going to be very helpful for you in the exam, in your SAC, and of course just doing your textbook questions. Well, that is it for today, guys. If you did enjoy the video, please leave a like, subscribe to hok'stutoring YouTube channel, and I'll see you in the next video. Bye!